All right, this week we are doing the single and double replacement reactions in Chemistry 112. And so to walk you through this lab, it's a series of 14 different reactions. Some of them are single displacement, some of them are double replacement. So displacement, replacement, those are both synonymous, and we'll go over those terms in a little more detail in lecture. And we'll talk about even, metathesis reactions, which is another word for the double replacement reactions. And so what I'm going to do is I'm going to show each of those reactions for you. I'm going to be performing them in test tubes in a micro scale. And so you'll be able to observe them, and then based off your observations, you can write down what you see. Again, what evidence do we know? What evidence do we see that a reaction is actually occurring? And then based off that, we can then take a look and see what would the products be, and if we do produce products, then what are their names going to be. And so we'll talk a little bit more about that, but for this first part, I just kind of want you to look at the reactions, make your observations, write down the things that you can tell to say that those reactions are actually happening. All right, my first reaction that I'm going to be doing is taking barium chloride, which is already here in this test tube, and I'm going to take barium chloride and add some sodium sulfate. There we go, barium chloride plus sodium sulfate. That was reaction number 1. All right, reaction number 2 is solid zinc metal. Right, so you can see there's the solid zinc metal, and I'm going to add hydrochloric acid to that. Right, so here we go, zinc metal plus hydrochloric acid. And there you go, zinc metal plus hydrochloric acid. All right, this is reaction number 3. In the test tube, I have aqueous sodium phosphate, and to that, I'm going to add aqueous copper 2 sulfate. All right, so there is sodium phosphate and aqueous copper 2 sulfate, and it's the lovely, what we like to call Smurf blue. All right, reaction number 4, solid copper metal. You can see it sitting there in the bottom of the test tube, and to that we are going to add aqueous silver nitrate. All right, that one we're going to let sit, and we're going to come back to it. Let me give it a stir. All right, we're going to come back to that one. We're going to let it sit for a little while, and we'll come back to it later. But you can kind of, right, maybe see some changes happening to the surface of the copper as far as color changes, right? Maybe if I get the aerial view, right, looking down on the copper. Nope, that's not working. Okay, there's my copper metal in the silver nitrate. And so now maybe you can see a little more clearly as far as what the color change is in that sample. Okay, so there you go. There's copper metal plus silver nitrate. Okay, now we're moving on to reaction number 5. This is solid sodium bicarbonate, and I'm going to add acetic acid. Sodium bicarbonate plus acetic acid. All right, reaction number 5. Okay, we're on reaction number 6. This is aqueous nickel nitrate, kind of a greenish blue aqua color, and we are going to add aqueous sodium hydroxide. Nickel nitrate plus sodium hydroxide. Give it a shake. Gelatinous would be the word I would use to describe that. All right, now on to reaction 7. This is copper metal. And to the copper metal, we are adding aqueous zinc nitrate. Copper metal plus aqueous zinc nitrate. Let's move that over here. See if you notice any changes to the surface of the copper. Okay, we'll come back to that one too. Okay, now we're on to reaction number 8. This is aqueous potassium chloride. And to that, I am going to be adding some aqueous silver nitrate. Let's see what happens. Ooh. All right, there we go. Reaction number 8. Aqueous potassium chloride plus aqueous silver nitrate. Okay, reaction number 9, hydrochloric acid plus sodium hydroxide. There you go, okay. You can see the two solutions mixing. The other thing I could tell you is that the test tube is warm, that this reaction is releasing heat in the process. Mix that up. Okay, there we go. Sodium hydroxide plus hydrogen chloride, hydrochloric acid. That was reaction number 9. Number 9. Okay, reaction number 10. Aqueous sodium carbonate, not baking soda, sodium carbonate dissolved in water, and to that I'm going to add cobalt-2 nitrate. Cobalt-2 nitrate. Looks like cotton candy. It does not taste like cotton candy. Guarantee you that because, right, the cobalt nitrate label says harmful if swallowed, may cause cancer. Yes, harmful indeed. There is my sodium carbonate plus my cobalt-2 nitrate. Okay, reaction number 11, zinc metal, which is there in the test tube. And I'm going to add aqueous lead-2 nitrate to that. Appears that my zinc has changed color. It's not shiny silvery anymore. Right, and you can also see the lead nitrate bottle. Harmful if swallowed oxidizer, which means that it produces lots of oxygen, which can lead to severe reactions. Zinc metal plus lead nitrate. Reaction number 11. That was it, 11. Okay, reaction number 12. This one, watch closely. This is aqueous sodium chloride plus aqueous potassium nitrate. Okay, there you go. Did you see it? Yeah, no, me neither. There was no reaction. Okay, here I have a strip of magnesium metal, and to that, reaction number 13, I'm going to add acetic acid. So there's the metal in the test tube. We'll stick that in the rack. All right, and then I'll add the acetic acid and we'll see what we get. Woohoo! It's doing something. Okay, I told you earlier that we were going to come back to reaction number 7, the copper metal plus the aqueous zinc nitrate, and there it is. And from my perspective, sitting on this side of the camera, it looks no different. Looks the same. Go back to now reaction number 13, magnesium metal plus acetic acid. Still getting bubbles. Okay, now we're on reaction number 14. This is aqueous iron 3 chloride. And to that, I'm going to add aqueous ammonium hydroxide. Ooh. Did you see that? Ugh. All right, that's my official comment. Ugh. All right, well that's it. That's the end of this lab, and so now your task is to write out chemical reactions for all the reactions you saw. If no reaction happened, then just simply write NR to indicate no reaction. But for each of the reactions that did happen, be sure you write a balanced chemical equation, include the state of each species, each chemical in there, so whether it was a solid, a liquid, a gas, or whether it was aqueous. And then you can also include the names of all the products. So when you have your A plus B, what are the names of the compounds that were formed? So, and then indicate whether it was a single replacement reaction or a double replacement reaction. So that will be it. Hope you enjoyed that, and I'll talk to you later.